Boom. All right. We might be able to hear you. I don't know. So for number 20, the quickest route, this is a pretty common question. It's a little complicated because you got like a right triangle element. Let's just draw a picture, I guess. She's 2 miles offshore in a boat. So let's say this is the shore here. Well, let's say this is the shore here. She's out here in the water. And we know that she is 2 miles offshore for some reason. All right. And she wants to reach a coastal village 6 miles down. So she wants to reach some village over here. And we know this whole distance here is 6 miles. Okay. She can row 2 miles an hour and she can walk 5 miles an hour. Where should she land her boat? So she's got a couple options, right? She can row right to shore and then walk all the way down the 6 miles. She could row the entire way in the water all the way down to that village, or she could land somewhere in the middle.
She can only row 2 miles.
2 miles an hour. It's a rate.
Oh, so she's not restricted to.
Yeah, no. She can row 2 miles an hour. So what's going to happen for a question like this is she's going to row somewhere into the middle, because the trick is she wants to make her distance small, but the smallest distance would be for her to row right to the village. The problem with that is she rows really slowly. So that's not the best option for her. So somewhere in the middle is going to be the best option. So really, just like we talked about the other ones, you got to think about what can she really decide. And the only thing that this poor girl, does she have a name, Jane, can really decide is where she lands. And that's going to pop up in the form of variables. And basically, she can decide how far down she should row down the shore. And if that side, if we call it x, then the other side of that has to be what? See, we talked about it. You don't want to call it a new variable because what's the whole distance have to be?
6.
Whole distance is 6. Yeah. So we want this to be 6 minus x. Okay with that? And what we want to do now is minimize the time it takes her. Okay? So we got to think about this using our equation. Basically, everybody knows this, that distance is equal to the rate you travel times the time you travel, right? But we want to minimize time. So I'm going to solve this equation here for time. And the time it takes her is going to be the distance she's traveling divided by the rate at which she travels. All right. Are there questions on this? How long is it going to take her? She has basically two lengths in this trip. The length she rows and the length she's going to walk. How long is it going to take her to walk this distance right here? Using this equation. The time it takes her to do this, which I'm going to call t sub 1. What's the distance she's going? 6 minus x. How fast is she going? 5 miles an hour. So the time it's going to take her is 6 minus x divided by 5. Whoa there, Chief. We okay with that? Because she can walk 5 miles an hour. The time it's going to take her to do this distance here, well, we don't have an expression for that distance. Okay, what rule do we have to use to find that distance then? We're going to use Pythagorean theorem. So this distance right here is really the square root of x squared plus 4. So the time it's going to take her, which I'm going to call that time 2, is really the distance she has to go, which is the square root of x squared plus 4, divided by how much time it's going, or her rate at which she's traveling, which is what, 2? 2. And we want to minimize her total time. Yep, so we say, I usually do like capital T or something. The total time it's going to take her is 6 minus x divided by 5. Hey there, Chief. Man, this stylus is... Okay, 6 minus x, that's the same thing as just multiplying that by 1/5. Okay, rather than make it a fraction, because, I mean, sometimes you guys want to do the quotient rule when you don't need to. So write it like that. And then this one is going to be plus 1/2 times that square root. Okay, and that was a tough one to set up. We've never done one like that before. But now that we have an equation for it, we want to minimize it. All we're going to do is derive it. Okay, so the derivative, which we're going to write as dt by dx, is equal to negative 1/5. You derive that first part plus, it should be 1/2 times the square root because there's already a half there. It's 1/4. It's going to be x squared plus 4 times 2x. Any questions on that one? Where that derivative comes from? That's the chain rule. So the 2x is up there because you got to drive the inside. Okay, normally let me write it back here, like times 2x back here. I just put it in the numerator. Okay? And now I want to know where that's 0. So, to find out where it's going to be 0, we're going to get this common denominator here. Or actually, well, we can do this a couple different ways. Guessing and checking would take us forever. We can get a common denominator. We can move like the 1/5 over and cross multiply and all that good stuff here. But because usually we want to get a common denominator, especially when we're talking about increasing, decreasing, we want to keep it as a fraction. So our common denominator is going to be 20 times the square root. Okay? So we're going to get negative. We got to multiply that first fraction by 4 times the square root. We got to multiply the second one by 5. So it's going to make this a 10x. And that should be a 20, right? Again, all we're doing here is getting that common denominator. And now I need to know where that's 0. And guys, the reason why I say you should get a common denominator instead of just moving things to the other side and cross multiplying is because if you get rid of that denominator, sometimes you lose a value that makes the derivative undefined. All right, in this case, since it's x to the square of x squared plus 4, that's never going to be 0. So that doesn't really matter in this particular question. How do I find out where that numerator is 0? What do I got to do? How do you handle something with a square root? What are we going to have to do to both sides eventually? Liana? We're going to have to square both sides, but we don't want to square both sides right now because then we're going to have to FOIL and everything. It's going to be nasty. So usually we want to get that square root all by itself. Can y'all do that? Do you know what I'm talking about here? What's the square root going to equal, Lauren? How about I get it all by itself? No, we want to multiply by the square root here. I'm talking about, so we want to know where this fraction's 0. It's going to be 0 when the top is 0. Yeah, 10x over 4. Cool, which is the same thing as 5/2 x. And now we're going to square both sides. Although this seems kind of nasty, it's going to work out relatively nicely. If you square both sides, you get this. What am I going to do next, Haley? What are we going to do next? We got to get our like terms together. Doesn't equal 0. What do we got to do to both sides here? What would it be 0? We got to subtract off x squared from both sides here.
Oh, okay.
Cool. So here, you guys with me? We do a minus x squared minus x squared. So how many x squareds do we have over there, Haley?
Now you have 21 over 4.
We do have 21/4 x squared. How am I going to solve that, John? How do we solve that? Multiply by 4 and then? Yeah, so we get 16 over 21 equals x squared. So then I'm going to take the square root of both sides. So you get that. And if you want to rationalize that, you can. And it would be 4 root 21 over 21. What's the significance of this point? What is this, Chi-Chi? It's a critical number, which means what, though? What are we trying to do? Yeah, we're trying to minimize time. Okay, so this is going to end up being the distance she should row down shore. Okay, because remember, we called it x right here. That's the distance she should row up shore to land. All right, now to check and make sure it's a minimum, we've been doing this, we're going to make a number line. So we go back all the way up to our derivative, and this is going to be kind of weird, but our number line, What's the shortest distance